I am off to go find the coldest thing that I can get my hands on. And I cannot think of a more fitting place than this. Speaking of cold things, we all know that canned air can get things cold. But why? This can has pressurized liquid difluoroethane. Now, difluoroethane has a really low boiling point. That means when I push the nozzle, it escapes really quickly because it is boiling away. Now, we use something else that has a really low boiling point. In fact, it is the lowest of all the boiling points to cool things on the James Webb Space Telescope. And that element is helium. Helium's low boiling point has come in handy in a number of ways on this mission. The Webb telescope traveled from Goddard Space Flight Center to Johnson Space Center to be tested in Chamber A. Now, this is the only thermal vacuum chamber large enough to fit Webb. Chamber A even got an update so it can use helium to get even colder. We also use helium in a special refrigerator called a cryocooler on the telescope itself. Now, one of the reasons that Webb has a cryocooler is because it has to operate at very cold temperatures. This is because it detects in the infrared spectrum of light. Infrared is something that we experience as heat, and so the telescope needs to avoid any sources of heat that do not come from the cosmos. Webb, in fact, is so sensitive to any infrared light that the science instruments need to be cooled to avoid detecting heat it creates by just operating. 3 of the instruments are cooled passively by sitting on the cool side of the sun shield. The last instrument, MIRI, needs to be cooled more than the other instruments, to 7 degrees Kelvin, using the cryocooler. Now, 7 degrees is unimaginably cold. I have here the coldest thing that I could get my hands on. Ooh. Might as well use this stuff up. And it is dry ice. And this is still 194 degrees Kelvin, much warmer than Webb will be at its coldest point. All right, we know that Webb has to get cool using the cryocooler, but how does helium make it cool? It's because the atoms are really small and can move really fast. So helium only has 2 protons and 2 electrons. That means it is super light, and it means that the gases move really quickly. That's why it tends to float away. And because the gases expand so quickly, it also means that it also cools things really quickly. So when things go from a pressurized liquid to a gas, they tend to cool. You see that same effect if you use a pressurized pot. When it's liquid and boiling, it is very, very hot. The steam escaping it actually cools really rapidly. If you were to put your hand above, right above where that steam is coming out, it's gonna be really hot. But even just 1 foot above that, and that air is touchable. This is called the Joule-Thomson effect. If you blow on your hand with an open mouth, the air is gonna be hot. But if you purse your lips, the air has to expand more rapidly, and it has a cooling effect. The cryocooler's liquid helium expands and contracts, and expands again in a chamber similar to this. And because it needs to get even colder, it has 2 chambers. And this is going to allow us to see the developing universe.